Welcome to our lecture on the first pass effect and enterohepatic recycling. So these two factors will be considered when we are going to administer a drug via the oral route. Orally administered drugs are available in oral dosage forms, and this include tablets, boluses, powders, pellets, capsules, granules, syrups, solutions, suspensions, and paste. We also have other specialized delivery systems, including enteric-coated tablets and sustained action or controlled release preparations. Of course, we have to define some of the major terms that are included in this description. We have boluses. So, of course, when we say bolus, that is a single dose of a drug that is given over a short period of time. We also have the difference between a solution and a syrup. So of course, when we say syrup, that is a viscous or a liquid consisting primarily of sugar or any other sweetening agent. When we say solution, that is a homogeneous mixture formed by dissolving one or more active ingredients. We also have the suspension. So basically when we say suspension, this is a heterogeneous mixture in which the solid particles are spread throughout the liquid without dissolving in it. So what happens to a drug that are administered orally or per os? So the drug administered are exposed to low pH ranges, digestive enzyme, intestinal microflora, and ingested that vary greatly among species. Of course, these factors will vary according to whether the animal is a ruminant or a monogastric. When the drug is absorbed from the GIT, particularly in the duodenum, it enters the portal circulation and passes through the liver before reaching the systemic circulation. So this diagram here shows the schematic diagram, what happens to a drug that are administered per os. So the drug again will enter the GIT, particularly the stomach and the small intestine or the duodenum. So it will undergo absorption, and of course it will be drained to the liver, and in the liver it will undergo the metabolism before it will reach the systemic circulation. So this diagram shows the different mechanisms and pathways whereby drugs will be absorbed in the GIT. So this represents the drug absorption pathway. Absorption into the blood circulation, it happens in the intestine, particularly in the small intestine or the duodenum. So within the intestine, you have the presence of the villi, and the villi will increase the surface area for the drug absorption. These are the different pathways by which drug will be absorbed. We have the paracellular pathway and the transcellular pathway. We also have here the different mechanisms that are important for the absorption into the systemic circulation, as well as the use of the permeation enhancers in order to increase the absorption of certain drugs. For orally administered drugs, a major pathway whereby it undergo before it will be absorbed into the systemic circulation is the first pass effect or the first pass metabolism. This is a high degree of metabolic transformation occurring before the drug will be able to reach the systemic circulation. What is the importance of the first pass effect and where is it located in the body? So the first pass effect is a phenomenon in which the drug gets metabolized at specific locations in the body. For its significance, it can result in a reduced concentration of the active drug upon reaching the site of action or the systemic circulation. It is often associated with the liver since the liver is considered to be the major site of drug metabolism or biotransformation. Aside from that, it can also occur in the lungs, the vasculature, the GIT, and other metabolically active tissues in the body. This diagram shows a schematic diagram of the first pass effect or the first pass metabolism. So again, this is true for those drugs that are orally administered. So when the drug will be administered orally, of course, it will go through the gut, the stomach, and the intestine, to be absorbed in the small intestine or the gut wall. So within the small intestine, there are presence of certain important enzymes. For example, the CYP33A4, the cytochrome P450, 3A4, which is an important enzyme present in the intestine. It is also present in the liver. And this enzyme is responsible for the metabolism of about 50% of medicines in human medicine. So during absorption in the gut wall, particularly in the enterocytes, the drug will undergo intestinal metabolism, and this is also under the first pass effect. After that, the drug will be reduced, and the drug will be absorbed through the hepatic portal veins, so it will be drained into the liver, and when it reaches the liver, it will again undergo another series of metabolism in the liver, since the liver is considered to be the major organ for drug metabolism. So that is also known as the first pass effect in the liver. So after that, that is the time that the drug will now be um, available for systemic, to reach the systemic circulation. What is the clinical significance of first pass effect or the first pass metabolism? So this phenomenon is particularly significant for those drugs having a high first pass metabolism. Examples of drugs with a significant first pass effect are these drugs here. For example, we have here the beta blockers. Example of a beta blocker is the propanolol. We also have the morphine and the calcium channel blocker verapamil. So for example, in the case of the beta blocker propanolol, it is in terms of its bioavailability, it is only 26% bioavailable because about 75% or 85% is metabolized by the liver before it can reach the bloodstream or the circulation when the drug is given orally. So this one here represents the oral drug administration. The drug will be reaching the GIT, the stomach, and the small intestine. So it will undergo absorption in the small intestine, but before it will be absorbed, it will still be metabolized in the GIT, particularly in the intestine, by certain enzymes that are present in the intestine before it will reach the portal circulation. So in the liver, again, it will undergo another round of first pass metabolism before it will enter the systemic circulation. So in the case of the propanolol beta blocker, it is said that only about 26% of the drug will be bioavailable in the systemic circulation. We also have the morphine. So morphine is an opioid drug. It is considered to be 30% bioavailable when it will be given orally. So this is because about 70% of the drug will be metabolized by a first pass effect in the GIT as well as in the liver. Because of that, morphine is usually given via the subcutaneous route injection to bypass the first pass mechanism. So other drugs with significant first pass effect are indicated here: nitrates, lignocaine, testosterone, verapamil, and salbutamol. A very important pharmacokinetic terminology associated with the first pass effect as well as the absorption of drugs in the body is bioavailability. So what is bioavailability? It reflects the fraction of the drug that is absorbed into the systemic circulation. So that is the bioavailability of the drug. So how do we measure the bioavailability of the drugs? Experimentally, this can be measured by comparing the area under curve, or the AUC, shown in this formula. Area under curve, or the AUC. So this includes the serial measurement of the plasma concentration of the drug made following the oral administration, and it will be compared to the intravenous injection, which is by definition produces 100% bioavailability. So the reduction in the AUC after oral administration can result from numerous mechanisms. So So this diagram here represents the area under curve of a drug that is orally administered or per os. And we also have here the AUC, area under curve of the drug that is administered through IV. So again, when we administer a drug through IV, it will not undergo the same process that the orally administered drug undergoes. So uh, it will not go through the GIT. It will not undergo the first pass effect or the first pass metabolism. That is why the bioavailability of the drug or the fraction that is absorbed, the fraction of the drug that is absorbed into the systemic circulation for IV administered drug is 100%. On the other hand, this is the bioavailability of the drug that is administered orally or per os. Our example here is propanolol. So it is said that the bioavailability or BA of propanolol is about 26 plus minus 10%. So as you can see here, of course, the peak bioavailability of propanolol after oral administration is only about 26%. Again, this is because propanolol is a drug that undergoes a significant first-pass metabolism. So for example, when this drug will be administered orally, so it will undergo a significant first-pass effect in the GIT lumen or in the GIT wall, the intestine, before it will reach the portal circulation in the liver. So again, it will still undergo metabolism in the liver before it will reach the systemic circulation. For the formula for getting the bioavailability, we have here the area under curve per os over the area under curve IV times 100 to get the bioavailability in percent. So the reduction in the AUC after oral administration can be due to different mechanisms. Number one of that is the pH or the bacterial mediated metabolism of the drug within the GIT. We also have the incomplete drug absorption from the GI tract. So that is also one of the disadvantages of the GIT absorption because there is an erratic absorption. You cannot predict the absorption when you are going to administer a drug orally. Metabolism within the GI epithelium, so that is under the first pass effect, and that is through the cytochrome P450 3A4. Excretion back into the GI tract by P-glycoprotein in the GI epithelium, hepatic metabolism, or biliary excretion into the GI tract. So this reduction is collectively known as the first pass effect, reflecting the loss of the drug via its first pass through the GI, tissues, and the liver before it reaches the systemic circulation. Another important pharmacokinetic feature of those drugs that are administered orally is the enterohepatic circulation. So some drugs undergo enterohepatic circulation where they are absorbed, conjugated into the liver, excreted in the bile, into the small intestine, and again deconjugated by the intestinal flora and then reabsorbed, all increasing the persistence of the drug for as long as recycling takes place. So this diagram here represents the schematic diagram of the enterohepatic recycling. In this case, we have here a drug that is orally administered. It will be absorbed in the GIT. It will go through the portal circulation. It will undergo the first pass effect before it will reach the systemic circulation to act on its receptor sites or before it will be eliminated in the body. For those drugs that are considered to be, there are certain drugs now that will undergo enterohepatic circulation wherein the drug will be secreted or excreted into the bile. Then the bile will be excreted into the small intestine. And after that, in the small intestine, the bile containing the drug will again be conjugated, deconjugated, and reabsorbed in the duodenum, for example. So there is, now as we can see, there is a cycle wherein after the drug will be secreted into the bile. So after the secretion of the bile, it will again be um, absorbed by the GIT and goes back to the liver and to the tissues. So this phenomenon is very important because it will increase the resistance of the drug or the presence of drug in the body. So as long as the drug is present in the body, it will be available to act on its receptor. It will produce an effect, or when we are going to increase, for example, the concentration of the drug in the body through enterohepatic recycling, and when we are going to take continuously the drug, so it can lead to toxicity. Enterohepatic circulation is also defined as the circulation of the biliary acids, bilirubin, drugs, or other substances from the liver to the bile, followed by entry into the small intestine. And in the small intestine, it will be absorbed by the enterocyte and transported back into the liver, as shown in the figure. Again, this is important concept, particularly in the field of toxicology, as many lipophilic xenobiotics undergo this process, and when there is continuous circulation of the drug in the body, taking in a drug continuously will cause toxicity, and again, it will cause the liver damage. This diagram shows the mechanism of the enterohepatic recycling or the enterohepatic circulation. So the liver plays a major role in the enterohepatic circulation because it is the one that will it will metabolize the drugs or the xenobiotics, and it will also be the one to produce the bile. The bile will be secreted into the gallbladder, so the drugs will come with it. It will be drained into the small intestine, and within the small intestine, it is where the reabsorption of the drugs and the bile will also take place back into the liver. So the intestinal microbiota in the intestine plays a central role in the enterohepatic recycling phenomenon. So the enterohepatic circulation is important because it increases the elimination half-life of many drugs. So when there is an increase in the half-life of the drug, it will also cause the prolonging the action of the drug in the body, and also cause the multiple peaks in the plasma drug concentration, as well as the time profile, which are frequently elusive in terms of the pharmacokinetic modeling. So the importance again of this enterohepatic recycling is that instead of the drug being metabolized and being excreted in the body, what happens is through the bile that is secreted by the liver, some drugs will undergo reabsorption back into the liver from the intestine, and this will prolong the half-life of drugs in the body, contributing to its toxicity. This diagram shows the pathway that the drug undergo, particularly the orally administered drug that will undergo before it will reach the systemic circulation. So for orally administered drugs, before they will reach the systemic circulation, they will still undergo a certain degree of metabolism in the gut wall, in the intestinal epithelium, and in the liver before they will be able to reach the systemic circulation. And this is known as the first pass effect or the first pass metabolism. So again, the significance of the first pass effect is that it will reduce the bioavailability of our drug. Also, there are certain drugs that will undergo enterohepatic recycling, wherein the drug will be secreted together with the bile, the liver, and it will be secreted back into the intestine, and in the intestine it will be acted upon by microbial enzymes, so that microbiota in the intestine so that it will be reabsorbed back into the uh, circulation and into the bloodstream. So again, the significance of this enterohepatic recirculation is that it will prolong the elimination half-life of the drug so that it can eventually lead to toxicity.